do a walkthrough and talk through of your Pear Deck review for Chapter 3 from yesterday. I will go back through the slides and we will discuss the correct answers of what you should have chosen. You should have been able to go into Google Classroom and get your Pear Deck takeaway so you could see your answers. And if you didn't, you can just kind of read along here as a review as I go through the answers. So the first one said, in Rutherford's gold foil experiment, most positively charged particles passed through the foil. A few particles were deflected. This caused Rutherford to infer, and your options were that electrons move in orbits around the nucleus of an atom, that an atom's positive charge must be clustered in a tiny region in its center, that electrons have almost no mass, that an atom consists of negative charges scattered in a ball of positive charge. The correct answer should have been B, that an atom's positive charge must be clustered in a tiny region in its center. So as those particles passed through and got sharply deflected, that showed that there was that positive charge very clustered in a tiny region, the center of the atom. Your next question, scientific theories often make use of blank, which are representations of an idea to help scientists understand what they cannot observe directly. That would be models. Scientific theories often make use of models, which are representations of an idea to help scientists understand what they cannot observe directly. Mendeleev created the first periodic table by arranging elements in order of decreasing atomic mass, increasing atomic mass, increasing atomic number, or increasing melting points and densities. The first periodic table by Mendeleev was created based on increasing atomic mass. We know that today we arrange the periodic table based on atomic number. The atomic mass does go up as well, but he actually created it based on increasing atomic mass. The series of electron orbits in Thomson's model resemble planets orbiting the sun or the layers of an onion. It was not Thomson's model that resembled planets orbiting the sun or layers in an onion. It was Bohr's model. The atomic number of an element is based on mass of its nucleus, number of electrons around its core, number of protons in its nucleus, or the number of neutrons in its nucleus. And we know that the atomic number is based on the number of protons in the nucleus. Each element is given a specific blank that usually consists of one or two letters. Chemical symbol. Each element is given a specific chemical symbol that usually consists of one or two letters. From an element's location in the periodic table, you can predict its properties, its chemical name, its chemical symbol, or when it was discovered. The correct answer is its properties, choice A. You can sort of know what its properties are, how it might react with other things based on where it is located in the periodic table. The modern periodic table is organized according to atomic mass, and we just mentioned this a few moments ago. So the modern periodic table is not according to atomic mass, it is based on atomic number. In general, which of the following statements about metals is true? Metals need to be stored in sealed containers for safety. Metals are malleable, ductile, and can carry an electric current. Metals are highly reactive substances, or metals do not react with oxygen. The correct answer is B. Metals are malleable, ductile, and can carry an electric current. Columns of elements in the periodic table are called either group or family. Remember, periods are the ones that go from side to side. The rows are periods. The columns are groups or families. The two most common alkaline earth metals are, and we may not have discussed this very clearly in any of our discussions, but it was in the book and it might have been a question on one of your worksheets. The two most common alkaline earth metals are copper and zinc, iron and silver, sodium and potassium, or calcium and magnesium. The correct answer is D, calcium and magnesium. Those are the two most common alkaline earth metals. The horizontal rows in the periodic table are known as groups. And again, we just talked about this a second ago, the horizontal rows are known as periods. So rows are periods, columns are groups or families. At room temperature, get rid of that. At room temperature, more than half of the non-metal elements are, at room temperature, more than half of the non-metal elements are, where am I looking for this to see what they're going for? Choose an option. Sorry. I need to give you your options and I need to find where they are. Okay. Alloys, gases, liquids, solids. At room temperature, more than half of the non-metal elements are alloys, gases, liquids, or solids. And if you look, the non-metals are on which side of the periodic table? On the right. And if you look towards the right at all of the non-metals, you will see that the majority of them, or at least more than half, are gases. Choice B. Elements that easily transmit electricity and heat display the property known as conductivity. They can conduct heat, conduct electricity. We say that is conductivity. The elements that do not ordinarily form compounds are elements in the carbon family, metals, halogens, noble gases. The correct answer is D, noble gases. They do not generally form compounds. They don't tend to combine with other elements on the periodic table. Non-metals can be found on the left side of the periodic table. And I just mentioned this in a previous question. Non-metals are found on the right side of the periodic table. Metals are on the left. Metalloids are in the middle between the two. Beta radiation consists of particles that are identical to helium nuclei, hydrogen atoms, X-rays, or electrons. If you remember from a discussion a couple days ago, beta radiation gives off that particle that is much like an electron. So the correct answer is D, electron. The spontaneous emission of radiation by an unstable atomic nucleus was named what by Marie Curie? She is the one who named radioactivity. Radioactivity. Measurements of half-life make radioactive isotopes useful for radiation therapy, tracing oil spills, building shields to absorb nuclear radiation, or determining the ages of rocks and fossils. Measurement of half-life make radioactive isotopes useful for determining the ages of rocks and fossils. It is those half-life numbers that allows us to see how it degrades over time to determine how old rocks and fossils are. Atoms with the same number of protons and different numbers of neutrons are called alloys. That is false. Atoms that have the same number of protons but different number of neutrons are called isotopes. What are two ways that a proton and a neutron are similar? So if you look at this chart, you will see that protons and neutrons, if you compare them, they have the same mass. Both protons and neutrons have a relative mass of 1, and they are also found in the nucleus. So they have the same mass, and they're found in the same location. Why does an atom have no charge? So if we look at this, we see that the proton is positive, the neutron has no charge itself, and the electrons are negative. We know that the number of protons always equal the number of electrons. So if you have the same number of positive charges that you do negative charges, they will cancel each other out, and the charge of the atom then will be neutral. There will be no charge. So, and I don't have my writing tool on here today. So the number of positive charges are always going to equal the number of negative charges, because your number of protons equal your number of electrons. So since your positive charges are always equal to your negative charges, then there will be no charge. Why is it unnecessary to include the electrons when determining the mass of an atom? So if we look at mass, a proton is 1, a neutron is 1, an electron is only 1/1836th. So the electron is just negligible. It's insignificant when you're talking about mass. What contribution did Dmitri Mendeleev make to chemistry? And we know that he was the first person to come up with the periodic table. He created the first periodic table. Why isn't the atomic mass of an element usually given as a whole number? And if you remember, we talked about mass. Remember, isotopes are different forms of an element that have the same number of protons but different numbers of neutrons. And since that atomic mass number is the combination of the protons and neutrons, you will end up with different numbers. So the number that we see in the periodic table is an average of all of the different isotopes of an element. All right, that does it for your questions. So you have your takeaway with your answers, so you can compare to all the correct answers. You now have all the correct answers. I will say that the test tomorrow may be in a little bit different format. Some of these short answers and essay questions may be in the form of multiple choice. So you will see all these tomorrow on the test, but they may be in a little different form than they were in the Pear Deck, but all the information will be there. All right, good luck studying. Have a great day.